Hello and welcome to Lesson 12 in the online terrestrial navigation course. Today's lesson is on Mercator sailing. It's a lot like the mid-latitude sailings, just a couple of different equations you'll have to learn. As always, there's a link in the description of the video to a worksheet you can download and follow along with the lesson. If you haven't already done so, hop over to my Patreon page. There's a link to it in the description of the videos, and maybe throw me a few bucks for making these videos if you found them helpful. With that, let's jump right into the lesson. Okay, just like the mid-lat sailings, there are going to be two types of questions, and you'll always be given latitude 1 and lambda 1, and then you'll either be given a course and a distance and required to calculate lat 2 and lambda 2, or you'll be given lat 2 and lambda 2 and required to calculate a course and a distance. So far, everything's the exact same as the mid-lat sailings. Okay, if you're given a course and a distance, you're going to use the following equations to calculate um, lat 2 and lambda 2. And if you notice here, the equation for the difference in latitude is the exact same that you used for your mid-latitude sailing, where your difference in longitude is m times the tangent of the course divided by 60. Again, these equations are in Bowditch, but for some reason, Bowditch wants you to calculate everything in minutes of latitude. Uh, I've included the divided by 60, which gives you degrees of latitude. That's just personal preference. I prefer to work in degrees of latitude rather than minutes of latitude. Okay, and in the next instance, you'll be given lat 2 and lambda 2, and we'll use these equations to solve for your course and distance. Tangent theta equals d longitude times 60 divided by m, and then your distance is the same equation that you used in your mid-lat sailings to get the distance, d lat times 60 divided by the cosine of the course. So again, just like with the mid-lat sailings, you need to memorize these equations. It's two new ones so far, and know when to use them. And okay, so from here, you're probably already asking, what is M and where do I get it? Um, M stands for meridional parts, and we have to calculate M for both lat 1 and lat 2. If you imagine the round globe, as we flatten this thing out into a flat chart, you'll notice these lines of longitude, they get skewed a little bit, and we have to factor that in when we're calculating our distances. So we flatten it out and then we bring it to a perfect grid. There's a little bit of a skew there in your longitude lines, and that's where the M comes in these equations. So you go from a round globe, straighten out all the lines, then bring it to a perfect grid. So we're going to have to throw this M factor in here to calculate our distances correctly. Now if we imagine this, the red line here is the equator, and we have north latitude and south latitude. If we have an L1 in northern latitude, just a random latitude here at 29 degrees 38 minutes north, we're going to measure from the equator. That has 1851.5 meridional parts, and then we have L2 down here at 24 degrees 38 minutes north, and we measure from the equator, and we get 1516.1 meridional parts. Our equations use M, and notice we have M1 and M2 labeled here. Well, the way we get M is the number of meridional parts between L1 and L2. In this case, since both of our latitudes are on the same side of the equator, we would simply subtract the smaller number from the larger number, In this case, we get 335.4 for M, and that is the number of meridional parts between the two latitudes. It works the same way if we have latitudes on the south side of the equator. Here, if we have latitude 1 and latitude 2 on the south side of the equator, we would measure from the equator down to our 34 degrees 22 minutes south, and we get 2185 meridional parts. And then for L2 from the equator down, we have 1433.5 meridional parts. And here again, we just subtract the smaller from the larger, and we come up with 751.5 meridional parts between our two latitudes. Now, if L1 and L2 are on opposite sides of the equator, we have to do it a little bit differently. We'll measure down to L1, get 621.2 meridional parts, then measure up to L2, get 410.2. If our L1 and L2 are on opposite sides of the equator, we add M1 and M2. In this case, we get 1031.4 between our two. We need to know how to find M. And there is a way, if you have a copy of Bowdage and the same Bowdage that's available in the exam room, there is a table for finding meridional parts. It wants you to convert your latitudes into minutes of latitudes and then enter the table, come out with all types of different numbers. Personally, I just prefer to do it on a calculator, and this is the equation we would use to find M. So if we just pull two random latitudes like we would use in our problems after we've converted them to a decimal, we'll punch that into our Texas Instrument 30XA, same calculator we've been using for everything else. Here we're going to have to key in the decimal to 4 decimal places in all of them. I find that that lets us come out more accurate than if we would just key in 2 decimal places. You got to remember to put your parentheses, and if you're finding M1, you're going to use L1 here, and you'll use L1 here to get M1. And we'll do the same thing for L2. So we'll start with the parentheses. L1 is 29.633, 29.633 divided by 2 plus 45, and then we'll close our parentheses, get tangent log times 7915.7. Incidentally, that is the radius of the Earth. That's a constant. So 7915.7 minus, and here we put in L1 again because we're still searching for M1. 29.6333 sine times 23.2. That 23.2 is a constant. It's the Tropic of Capricorn, Tropic of Cancer, as far as the globe goes, and then we hit equal. We come up with 1851.5. That's going to be your M1. And then we have to go through the same process again, except we use L2 everywhere there's an L here, and we get M2. So we'll start our parentheses, 24.6333 divided by 2 plus 45, close our parentheses, tangent log times the radius of the Earth, 7915.7, minus the sine of the latitude, 24.6333, sine times the tropics, 23.2, equals 1516.08, so we could probably round that to 1516.1 pretty safely. Now, no, this equation is not printed in Bowditch. They give you a table. There's some instructions on how to use the table. Unfortunately, I do not have a copy of Bowditch with me at this point that I can cut up and make a PDF out of and show you how to use the table. If you remember this equation, it will give you M for everything that you need it for on these problems. That's how you get it. Okay, so from here we're going to walk through one of each type of the questions that you'll see on your Coast Guard exam. Question 1 here, lat 3724 north, long 17815 west. You head for destination at 3418 north, 178.25 east. Determine the course and distance by Mercator sailing. The first thing you need to ask yourself is, what equations am I going to use? Well, given L2 and lambda 2, we'll use these two equations and of course the equation to find M. And the first thing that we need to do is convert all of our lats and longs to decimals. You should be really familiar with that by now. Just let it play through here. If you haven't done lesson 6A yet, you can go back to 6A. It walks you through the conversion process from degrees to decimals. And then we just simply subtract the smaller from the larger to get our difference in latitude and difference in longitude. And you'll notice here the larger number is on the bottom, the smaller number is on the top. That's just a bad habit that I have. We just simply subtract the smaller from the larger. So we'll walk through calculating M1 one more time. And we're calculating M1, so we're going to use L1. We'll start our parentheses. L1 is 37.4. 37.4 divided by 2 plus 45. Close your parentheses. Tangent log times the radius of the Earth, 7915.7, minus the sine of the latitude, 37.4, sine times the tropics at 23.2 equals 2408.66. We can probably round that to 2408.7. And let's calculate it for M2 real quick. 34.3. So let's start our parentheses. 34.3 divided by 2 plus 45. Close your parentheses. Tangent log times 7915.7 minus 34.3 sine times 23.2 equals 2180.15. We can round that to 2180.2. And we subtract the smaller from the larger because both of our latitudes are on the same side of the equator. And we come up with 228.5 for M. Now that we have M, DL, and D lambda, we can calculate our course. And we're going to do it with these buttons on the calculator. Um, so D lambda is 3.333333 times 60 divided by M, which is 228.5. Equals second tangent. At this point, you could say 41.2 degrees as your course, and you could use that. And at the end of the problem, the longer your distance is, the further off your calculation is going to be. I think at one point, if we use that 41.2 or whatever course you come up with, or whatever theta you come up with, the longer the distance in the problem, the further you're going to be off. I think one of the problems when I worked through them, we were traveling something like 4,500 miles, and it ended up being 17 miles off at the end. So to keep from doing that, we're going to use the memory in the calculator. So when we get to this point, we're going to hit store 1, and we'll store that in our memory, and we can clear it. And then we'll just put that 41.2 on our scratch paper for theta. And now that we have theta, we can get the course, and it's the same way we got the course in our mid-lat sailings. Our D lambda is south, our D latitude is south, and our D lambda is west. So going from 180 to 270, we are adding. We're going to add theta to 180. But in this case, we're going to use our memory. Slide this over here, and we'll say 180 plus recall 1 equals 221, and we're going to store that number in our memory also. So you'll just hit store 1. We'll need that number in just a minute. So we have our course of 221.2, and now we calculate our distance. Okay, so D lat is 3.1 times 60 divided by recall 1 cosine equals. This is going to be our distance. The fact that we get a negative number here, that's of no consequence. We just drop the minus sign in front of it, and our distance is 247.18. We could probably round that to 247.2 fairly safely. If I can get the slide to advance here. Okay, and our answer comes out to be C, 221 degrees, 247.2. I would say our arithmetic come out pretty close on that one. Okay, so here let's take a look at question 11. Question 11 on the worksheet is where everything changes up. You're given a course and a distance, and you're going to calculate the L2 and lambda 2. And these are the equations you'll be using here. The same distance equation you used in your mid-lat sailing, and the uh, d lambda is the m times the tangent of the course divided by 60. So the first thing we're going to do here is convert our lat and long to decimals from lesson 6a. Okay, and at this point we need to determine the direction of the course as far as what quadrant of the compass it lies in. 135 is over here in the southeast quadrant. So we'll put our south and east up here with our latitude and longitude. And this lets us know that our correction, our difference in latitude and our difference in longitude, since our difference in latitude is going south and our L1 is north, we're going to subtract this correction. So go ahead and put your minus sign there, and we're going to the east, and our lambda 1 was west, so this correction will be subtracted. Had this been a northerly correction, we would have added the correction. Same thing with the longitude. Had it been a westerly correction, we would have added it. So east and east you add, west and west you add, west and east you subtract. Same thing with latitude, north north, south south, you add, uh, opposite directions you subtract. And this is our equation that we use. It's the same equation that we used for mid-lat sailing to calculate the distance. And we do it the same way with the same keystrokes that we did in our mid-lat. So let's go ahead and key that in real quick. The distance is 4505, taken from the problem, times the course of 135, 35, cosine, divided by 60 equals 5309. And again, here we ignore that minus sign because we've already gotten our correction over here. What you get on the calculator has no bearing as to what your correction actually is. That's why we put our correction in there first. So 530919. And we'll slide that over here to our latitude. And again, I have the larger number on the bottom, but that's 53.0919 minus 22.5833. We're just simply subtracting the smaller number from the larger number there. Okay, so now that we have L1 and L2, we can calculate the meridional parts. And we have to calculate meridional parts for every problem, no matter what they're asking for. So, okay, so let's calculate M1. We'll start by opening our parentheses. That's very important. 22.5833 is our lat. 22.5833 divided by 2 plus 45. Close our parentheses. Tangent log times 7915.7 minus L1 again, 22.5833 sine times 23.2 equals 1382.59. So we'll round that to 1382.6. And now we need to calculate M2 using L2, which is 30.5086. Make sure you calculate L2 and not DL. Pretty easy to get crossed up sometimes. So open our parentheses and 30.5086, 30.5086 divided by 2 plus 45. Close your parentheses. Tangent log times 7915.7 minus L2 again, 30.5086 sine times 23.2 equals 1911.9. That's going to be our M2. And because L1 and L2 are on opposite sides of the equator, we're going to add these. And we'll come up with 3294.5 for M. Now that we have M, we can calculate our d lambda. And we will do that using the following keystrokes on our calculator. So M is 3294.5, 3294.5 times the course of 135 tangent divided by 60 equals 54.9083. And again, just like in the d lat, we had a negative sign. We're going to disregard that negative sign. In this case, we just happen to be subtracting the corrections. You'll run across cases where you'll get a negative number on the calculator. Your correction says add it. You always add it. So we'll do 54.9083 as our d lambda. We'll slide that up here and subtract the smaller from the larger. We come up with lambda 2 of 102.5917 degrees west. So now we actually have the answers. We just need to convert that decimal back to degrees and minutes. So the way we do that is just bring the 30 down and multiply that decimal times 60. Here we have 30.5. So that's going to be 30 degrees, 30.5 minutes south. We'll drag the lambda 2 down here and do the same thing to it. 102 degrees, that 0.5917 times 60 comes out to 35.5. Bring that down, get it up out of the way so we can look at the answers that the Coast Guard gives us for our multiple guess. And looks like answer A is pretty close to what we calculated there. That's looks like, is that 1,200 feet off? I would say 1,200 feet over a distance of 4,500 miles is pretty damn close. All right, well, from this point, the rest of the video is just a step-by-step work through of each one of the problems. If you get stumped on them, just scroll through the video till you find the question number. Question 1 and 11 are the two that we worked, so it'll be back at the beginning of the video. Um, if you want to let the video just play out, give me some more watch time minutes on my YouTube channel. That would be greatly appreciated. Leave some comments. If you know a better way of doing it or something, drop us a comment there in the comment section. And if you haven't subscribed to the channel already, go ahead and hit that subscribe button. Let us know what you think. All right, thank you.